of the Road to Recovery, Phase 1, Identifying Causes of Bird Declines. Alrighty. Well, thanks everyone for coming to this first workshop in the Road to Recovery. This is the first of what we think may be several workshops leading from now into the fall. And this first workshop is identifying causes of bird declines. My name is Tom Will. I work for the U.S. Fish and Wildlife Service in the upper Midwest, and I've been a longtime member of the Partners in Flight community. I used to be an English teacher in secondary school. I worked a little while as a journalist. I traveled around the world a bit, and I even spent some time on Wall Street as a spy into that kind of life, and decided, no, that was not for me. And I think more than anything else, that what drives me is that I just simply can't imagine living in a world without the daily presence of birds in my life. I'll be serving today as your meeting moderator. I'll be introducing the speakers and the panelists for today's schedule, and I'll be moderating questions to the panelists from the audience. I want to say that this workshop was grounded in thinking by the American Ornithological Society Conservation Committee and the Partners in Flight Science Committee, and it was made possible through the generous contribution of the Knobloch Family Foundation. And of course, this set of presentations in the workshop was spurred by the publication of the 3 Billion Birds Lost paper that was published recently in Science, and which has really subsequently re-energized the bird conservation community completely, leading to increased commitment and hopefully increased funding, and then most of all, hopefully the societal will to that final result of bringing back 3 billion birds. The workshop was initially framed by a group of conservationists from all different perspectives in the bird conservation world that met in Georgetown, at Georgetown University in January of 2020. We framed the workshop in the context of other ongoing activities that had to do with bringing back 3 billion birds, and focused on this initial workshop as a science workshop, specifically to try and figure out what were the causes that were leading to bird declines. It was originally conceived as a face-to-face gathering at Asilomar. Obviously, COVID made that an impractical reality. And so what you're going to have today as this first session will be largely the first part of the agenda from the Asilomar meeting, which was really going to be taking up maybe a morning and a little bit of the afternoon in one of the 3 days at Asilomar. Really, we're in virtual format now, and this meeting has been by invitation, but we've expanded the group of dedicated bird conservation folks from that original Asilomar group of maybe 40 or 50 to this group, which is in attendance today, which is about 120 different people. By the last count I had, we had 31 individuals from, even though we were not trying to make an effort to really be representational necessarily in this meeting, we wanted experts in figuring out causes of decline. But we have 31 people from the U.S. Fish and Wildlife Service and other U.S. federal agencies. We have 12 participants from Canadian agencies. We have one participant from Mexico, Canabio, and also another participant from Mexico from academia. We have 27 representatives from non-government organizations like American Bird Conservancy and Bird Conservancy of the Rockies. We have 31 folks from academic institutions, 11 representatives from US joint ventures, and 2 people from state agencies. So that's sort of the rundown of the audience, and geographically we span the continent and a little bit even beyond the continent. I think we have 1 person from Europe participating. Now that we're not face-to-face, we are using this webinar format rather than a workshop per se. So we'll be working with presentations, a keynote speaker, some lightning or short talks, but we'll have opportunity for interaction with the audience via panel discussion on both days and a happy hour session tonight. And there's also a Google Drive folder with a file that will serve as a way in which folks can continue to contribute to the ongoing conversation. And we'll talk about that a little bit later on. A little bit about today's structure. I already mentioned that we'll have 2 introductory talks, and then one by Pete Mara and another by Ken Rosenberg, followed by the keynote by Steve Beisinger, and then some lightning talks and a panel discussion. I want to just say a little bit about the focus today. Today will be on identifying in a thematic and conceptual way some of the science pieces that might contribute to our ability to understand causes of decline. Tomorrow, the focus will be a little bit different. We'll be looking at actual examples of attempts to recover species using various methodologies and techniques, and to really dig into, by looking at real examples or case studies, trying to understand a little bit more about where moments of insight can occur. For the most of the day today, just a little bit about ground rules. We've disabled the chat until the end of the meeting. I sort of look at chat as kind of the equivalent of people checking their email or looking at phone messages during the presentation. So we really want to encourage the audience to listen to the presentations and pay attention to the content. And then there'll be opportunities for asking questions, and particularly during the final hour of today's session, interacting with the panel discussion. You can ask questions, both logistic and questions that are intended for speakers and panelists, by entering those questions into the Q&A option, which you can find at the bottoms of your screen. So that Q&A option replaces the chat, but I'm going to ask everybody to use it specifically, not for chatting, but for asking questions of the speakers or panelists. So with that, I'll introduce our first speaker. That would be Pete Mara. Pete's the director of the Georgetown Environment Initiative and the Laudato Si Professor in Biology and Environment, and also professor in the McCourt School of Public Policy at Georgetown University. Pete comes to Georgetown, most of you probably know this, after a 20-year career at the Smithsonian Institution, and most recently as director of the Migratory Bird Center there. Pete lives in Tacoma Park with his wife and 2 kids. He's an avid fisherman, a gardener, and a cook, and I can attest to his cooking expertise. And if you know Pete, then Pete will tell you there's only one way to fry an egg. So Pete, take it away.
Thanks, Tom. Everything good with the screen?
Everything's good.
Great, great. Well, thanks everybody for participating in this virtual workshop, especially all the speakers. We had wished this was going to be in person, but we are doing the best we can here. So let's hope this goes smoothly. We're really excited about what you're all about to hear over the next 2 days. As Tom said, and we'll repeat several of these things, I'm sure, over and over again, but this effort is an activity that stems from several discussions as part of the science committee at the AOS, as well as the Partners in Flight committees. And importantly, it's also an activity sponsored by the Knobloch Family Foundation. It's a science-based conservation foundation. If you don't know, it's a group that invests in science to inform conservation. And they use science to identify and protect the places that are important for wildlife. And one of the major focal areas of the Knobloch Family Foundation is migratory bird populations. And so it's really makes sense for them to support this effort. These next 2 days really represents that exact thinking. And so on the heels of our 3 billion bird paper that came out last fall, we envision and plan there to be several follow-ups to what we're doing these next 2 days, as Tom mentioned, and eventually we do still hope there to be an in-person meeting. But you don't publish a paper like we did on the decline of North American avifauna and then go back to your day job watching red start behavior or whatever it happens to be. So we've been thinking for some time, and not just us, Ken and I and Tom, a large group of us, in fact, have been thinking about what the response really needs to be. What have we been doing in conservation that's working? And more importantly, what are we doing that's not working? Because something clearly doesn't appear to be working, because we've just seen a net loss of 3 billion birds, 29% of the North American avifauna, 303 of 529 species declining, 57%. That's clearly suggests that something's not correct. And these declines vary across habitats. You've probably all seen these results. These slides will probably be shown several times today. Grassland birds are taking a big hit, but so are boreal forest birds, western forest birds, birds in tundra, habitat, even habitat generalists. Common species are now declining in ways that we didn't imagine they would before. But I think it's important to also think back in time and look at the context and look at when these things have happened before, because we've been here before, sort of. So let's look at some of these bird declines and crises like this in our history. Because in some ways, as I've said, this is not new, but in other ways, it's a completely new duck. One of the most influential moments in our history of bird conservation goes back to over 100 years ago, with the intentional shooting of herons and egrets for philo plumes. And this resulted in the passing of landmark legislation in the MBTA. It was critical. It was a watershed moment, and it resulted in policies and laws being passed that, in this case, even international treaties that have persisted until just recently, for the most part. But in this case, it was clear the smoking gun was clearly known. And so we were able to address that smoking gun and deal with it. And bird populations responded. But again, we knew what the problem was. Then in the 1940s, we were using DDT as an insecticide to combat mosquitoes. And then in Wisconsin, primarily initially, people were seeing dead robins, other dead birds. And it took some time for us to really understand the impacts, but several species were clearly sitting on scrambled eggs instead of nice hard eggs going through incubation. We saw massive declines in several species like peregrine falcons, bald eagles, brown pelicans. Most of you know the story, resulting in a landmark book, Silent Spring, that really is thought to spawn the environmental movement. It was critical, and out of this came the ESA and several other forms of landmark legislation that were important. So there was, again, this bird crisis. There was this watershed moment that created several important things. And in this case, I was at a spot yesterday on the Olympic Peninsula where I literally saw 10 bald eagles in one eye's view. It was impressive. So birds have responded. Then in 1989, Chan Robbins, John Sauer, Sam Droege, Russ Greenberg published a paper looking at population trends for 156 neotropical migratory bird species using breeding bird survey data. And it brought out the fact that there's major declines going on in several migratory bird species. The paper pointed to neotropical migratory birds, and it also pointed to tropical deforestation as primarily likely being one of the main causes, but it wasn't that specific in terms of where those declines were occurring. But again, after this paper came out, several key things happened. The start of Partners in Flight, the Smithsonian Migratory Bird Center was funded through Congress to the Smithsonian. The American Bird Conservancy was founded in 1994. So several mainly non-legislative things that occurred after this paper. But again, there were several really important things, landmark things that happened. And in this latest campaign, this one that started with the Robbins et al. Paper, these were really, I think of it when I look back at it, it was an awareness campaign to address broad scale threats. It wasn't really a campaign that was geared specifically at dealing with species or smaller groups of species, and especially in a full annual cycle approach. It really didn't do that as well as it could have, even though it pointed to tropical deforestation, didn't target limiting factors. That was what people thought the ESA did at the time. So as we sit here in the wake of this 3 billion birds paper, sort of like what happened with overharvesting of herons and egrets and the impacts of DDT, this is perhaps another moment in time for conservation. It's perhaps another chance to help change the national consciousness, because we've gotten so much steam, so much press on this, as well as the trajectory needed to save birds and the ecosystems that they depend on. We are all really witness in our lifetime to this decimation that's occurring to bird populations and other organisms, insects and a variety of others. For me, it's species like the common nighthawk that I grew up with, or eastern meadowlarks that were so common that are now sometimes really hard birds to find. Once common species that are no longer common. But it's up to all of us to really do something about this, to fix the problem, because something's just not working and we need to do all we can. So after the paper came out, we've got together and started to really start thinking about what's next here. What are we going to do next? And we reflected and we came up with what we think of as 5 game changers, or 5 game-changing actions that need to take place. In some cases, these things are happening. In some cases, not so much. And we need to really move these forward. So I'm going to sort of talk about these 5 game changers, things that are happening, are about to happen, or refer to exciting new developments that are really going to make the game playing field change. The first is one we call sort of an unprecedented coalition to address the bird crisis. So after the science report came out, major bird organizations representing mainly the paper's authors, but not just the paper's authors, came together to sort of sound the alarm about the paper and the bird crisis. Well, we need to continue to build this coalition and bring bird organizations and related groups together now more than ever with this unified message to nurture new and existing partnerships, to cross organizational and geographic boundaries. This needs to be international. It's not just in the US at all. We don't mean to imply that at all. It can't be. But we need to grow this, because it's only through collaboration, cooperation, and coordination that we really can achieve the sorts of conservation at the scale and scope necessary to reverse bird declines, as well as sustain healthy human populations, which also has to obviously be a big part of our goal. A second game changer is to advance science to identify what we've been referring to as sort of the smoking guns of bird declines. And I'll describe what we mean by that in a little bit, but it's really the limiting factors. So although broad threats and drivers of habitat loss are well known, we really don't know yet the specific limiting factors that are causing the declines for most bird species. That is, those that are not necessarily listed as threatened or endangered. These ones that are spiraling towards that status. But we need to continue to move forward on the broad scale threats. And it doesn't mean we're not doing both of these things. We have to. But we need to really focus in on some of these other species. And what are the limiting factors? What are the smoking guns? Can we do that? Can we get at those things? So I think what we're going to find is that in some cases we probably can, in some cases we probably can't. Or the problem might be, once we figure out what the problems are, maybe there's no real way to implement the management actions that we need to implement to stop the species from declining. It's another important piece of this whole puzzle. But there's lots of reasons here to be excited about the new day. There's exciting developments, both in things like eBird, which are giving us, visions of distribution and abundance of birds that we've never seen before. How birds move over the entire species across landscapes from winter to summer, across migration. I mean, it's transformational. New tracking tools that are coming down in price, that are coming down in size, that are giving us a different view of what individuals are doing over space and time, to the point where we can even look at direct mortality of individuals. And to bring all this together, there are new integrative quantitative approaches, and integrated population models and other sorts of things that may allow us to bring together the quantitative values, the vital rates, to really start to pinpoint where, when, and what in the annual cycle are driving these declines. These are all critical pieces of new developments that really could help us get to these smoking guns or these limiting factors. In these next 2 days, this is what we're going to be focusing on in part. There's also a new generation of conservation investment strategies that have emerged that combine the latest science, what we've just talked about, with a business planning approach to ensure that we get a strong return on investment for conservation, because investment dollars, conservation dollars, are not unlimited. So we have to be very careful. And as this new science becomes available through the approach we're advocating here, by first identifying where, when, and what the limiting factors are, these strategies will serve as roadmaps to recovery for species most in danger of future listing. Exactly what we want to avoid. We don't want these species to become listed, because then it's going to cost tens of millions, if not hundreds of millions of dollars. So we're ultimately saving money. In some cases, what's exciting is that there are already conservation investment strategies that exist for some of these species. There are some that are in development, and there are some that aren't, that we need to develop. But that process is in different stages of development. We want to help that process move forward. 4, as bird populations continue to decline and federal protections for these birds continue to be weakened, like MBTA, as is being done by this current administration, we need to view this as an opportunity for new and novel policies and legislation to be enacted that will ensure sustainable bird populations for generations to come. So even though the decimation of the MBTA seems like such a horrible thing, it is a horrible thing. We need to use that as an opportunity. In fact, right now, the Recovering America's Wildlife Act is planning to provide, will hopefully provide, dedicated and sustained funding targeting non-game species, birds like we're talking about over these next 2 days, at the state level. And in fact, the MBTA the Recovering America's Wildlife Act just passed the House last Thursday. It's on its way to the Senate floor. So there's reason to be really optimistic about bold new legislative action. Even though it sounds like such a daunting thing, it's actually happening. And finally, the coalition of bird organizations that came together, around the science publication implemented a highly successful media and outreach campaign that sounded an alarm that got worldwide attention for the bird crisis. That first phase was to share the scientific results of the report. Phase 2 was to report something we were referring to as these 7 simple actions that people could do in their own backyards. What we need to do now is a sustained phase 3, and that's what we're referring to this. It's a communication strategy that'll help to continue to provide a unified voice for bringing back 3 billion birds. So what we're going to do is start here. This is where we're going to start for the next 2 days, and that is to advance a science in a sort of a new road to recovery to reverse the declines. What are the highest priority species? Ken will be talking about this right after me. We're going to start exploring where the knowledge gaps are for determining population limiting factors. How do we get those data collected? And what's the plan for species recovery? This is the sort of things we want you all to start thinking about for these species that are in most trouble. In some cases, finding the smoking gun may be fairly straightforward, or the limiting factor. But it may not be. There may be all sorts of problems with identifying what that smoking gun is, because these birds occupy such large areas in many cases. Could be a breeding ground limitation, could be a winter ground limitation, could be something during migration, could be interactions. And it's probably not one smoking gun. It's probably multiple smoking guns that's really driving things. The days of DDT or over-harvesting are probably over. We know that the drivers of bird declines are varied. Habitat loss is probably the largest driver, and we can't save all places. But what we have to ask ourselves is which place, if we save or we manage differently, will give us the biggest bang for our buck? Is that a breeding ground location, somewhere on migration on the winter? To put that a different way, if we save or manage 1,000 hectares of black swift habitat on the breeding grounds, will that increase its population size as much as 1,000 hectares on the wintering grounds? That's the kind of question we have to ask. Similarly, with more direct sources of mortality, which of these, cats, buildings, towers, if we do something about one of these, will we have a big impact? And are these sources of mortality additive or compensatory? And how can we figure that out? How complex is that? But we have to start addressing this in ways that we really haven't in the past. And again, I believe that there's probably multiple and interacting threats, and all of these could be exacerbated by climate change. So we've got our work ahead of us here. This is going to be complicated. And that's why we've brought together these series of speakers so we can start to be much more strategic and focused on where to implement conservation action, at least on sort of a top tier of species that we need to be most concerned about, at least in the next few years. Tom, that's all I have to say. Ken, do you want to move into your presentation?
Yeah, Pete, thanks. That was a great framing of both the whole road to recovery and where we're sitting today at this webinar. So really appreciate that. Ken Rosenberg's up next. Ken is an applied conservation scientist at the Cornell Lab of Ornithology and in the American Bird Conservancy. He's been at the Cornell Lab for more than 25 years, and during that time, he's also been a great leader in Partners in Flight and other bird conservation initiatives, including being the chair of the Science Committee for Partners in Flight for more than 10 years and leading the science teams for the U.S. State of the Birds report. He and Pete are sort of the bookends of the 3 billion birds lost science paper that brought together the best assessment and monitoring data for over 529 species. And I'll just say that if you go on a long trip with Ken, you can expect a running commentary on herd birds, but with hours and hours of Grateful Dead tracks in the background. It's also rumored that in his past life, Ken had great dancing ability, and such great dancing ability that earned him Sandhill Crane as his officially bestowed bird totem. Ken will be talking about the road to recovery. Which species do we focus on first?
Thanks, Tom. Let's see. First, since I can't see myself or hear myself, is everything working, Tom? You see my presentation and can hear me?
You're good.
All right, thanks. Yeah, I'll give this presentation to my dog again. She's heard it several times. Yeah, so it's great that we have such a good group here. And again, I'll echo what Pete said, really sorry that we're not all together at Asilomar in California this week, but I think this is a great group that's come together. This is a great beginning to this whole process. So this workshop is really just the beginning. So my part today is to think about species. And we know, I mean, with between 500 and 600 species of birds breeding in North America, and we know that more than 300 of these species are in decline, that's pretty daunting just in itself. And with limited conservation resources, we really need to figure out what are the species in most dire need of attention right now. And we've been through these prioritization exercises before, but with the focus today for this process, what we're really interested in are the birds that may drop off this precipice, that are declining so fast, that have small populations, that they could slide into threatened and endangered status, require listing, require federal attention, that's just going to be so expensive. So we've developed a process for essentially filtering or sorting through these 500 to 600 bird species. And it is largely based on the Avian Conservation Assessment Database, the ACAD. And this is the database that Partners in Flight originally created as its prioritization database for land birds. But more recently, the ACAD has expanded to become a conservation database for all species from Canada to Panama. So that's more than 1,600 species that are now represented in the ACAD. And it presents critical information on each species in terms of its vulnerability to extinction or extirpation from various regions. And there are global and regional assessments that can be done with the information in the ACAD. And it sort of is a compilation of the latest, all the latest biological data in a very simplified format. And it's based on peer-reviewed methodology. And it's designed, a lot of the scoring parts of the database are designed to dovetail with BirdLife IUCN global criteria. And the ACAD, of course, has been the basis for Partners in Flight plans, other bird conservation plans, for the State of the Birds reports, and most recently, it's where we got most of the information for our science analysis. And this entire database, the ACAD, is housed and managed at Bird Conservancy of the Rockies, and it has been since its creation. So the core of this database are the vulnerability factors. And there are 6 vulnerability measures that are largely independent of each other, that are scored for every bird at the global or range-wide scale and also at the regional scale. We're primarily interested in the global range-wide assessment for these birds. And these factors are population size, the size of the breeding and non-breeding distribution, threats during the breeding and non-breeding season, and population trend. There are also some additional measures that only come in at the regional level. But for every one of these factors, each bird is scored on a scale of 1 to 5, with 5 representing the highest concern, 1 representing the lowest concern. So a bird with a very, very small population size has a high vulnerability based on that population size factor. So it would score a 5. And a bird with a very large population size would be a 1, and so on. And so this simple scoring 1 to 5 across these factors is the core of the ACAD database. And from that, we're able to derive a combined species conservation score for each bird, a vulnerability score. And this can range from 20 for a bird like Florida scrubjay that's going to score a 5 on everything. It has a tiny population, a small range, high threats, declining trend, all the way on the other end. A bird could score a 1, such as a great-tailed, a 4 in combined scores, such as a great-tailed grackle, because it scores a 1 on it. It just says very low vulnerability with respect to each of those factors. And based on that combined score, that's how we've come up with the watch list and the various categories of the watch list, the red watch list being species of highest concern in North America, and the yellow watch list in a couple of different categories, birds in that next tier of high concern. And we also can identify species that are not on the watch list based on their total vulnerability score, but they are showing steep population declines, specifically a 50% decline or more since 1970. So we get a PT, population trend score of 5. And so we have a set of birds that are common birds in steep decline based on that factor. And then the ACAD also houses the raw data and things like trends and population size estimates that are behind these scores, as well as their source information is all in the ACAD, and other ancillary information that's often critical for doing conservation assessment, habitat, geography. We've now added in information from the science paper on the amount of population lost, for example, for each bird. And what we're doing now as part of this process, and what we hope to do as next steps, is add additional information for these birds, pulling in what we know or don't know about migratory connectivity, what geographic habitat clusters these birds represent based on a new analysis that a group of Partners in Flight science folks have done. And in terms of who's working on this bird, are there recovery plans that have begun, conservation investment strategies, et cetera. So we have a bunch of blank columns now in this database that we want to fill in as we go, as we move this process forward. So there are lots of ways to slice and dice and sort of cut across the database depending on what your goals are for prioritizing species. We could look at the species of highest concern, but we could also look at species that have the greatest data gaps, or we could look at species that are sorted by habitat suites, et cetera. So there's a number of ways. When we say prioritization, it really depends on what the goals and the values are for that particular exercise. And what we're going to try to do here are find the birds that are in the most critical condition that it's most important for us to be focusing this new science on. So just a few examples of how you can sort through the database in different ways. And hopefully you can see that. You don't really need to see all the different species, but if you're just sorting by the highest level of concern, so that combined score, which can go up to 20, you see these birds that can score a 17, 18, 19 for combined score, salt marsh sparrow, rosy finches, birds like that. So these are the birds of highest conservation concern overall in North America. If you sort by declines, you get a very different list. If you're looking at the birds that are just showing the steepest population decline, you're seeing things like black swift and evening grosbeaks and swallows and grassland birds, some of which have lost 70 to 90% of their population since 1970. So it's a very different list. And then now that we have this new information on loss of abundance, if you were to sort by that and look at the species that have lost the largest number of birds, contributed the most to the loss of abundance in North America, that again is a very different list of birds and includes some very common species, including even some introduced species such as house sparrow and starling that are contributing to this overall loss. So we wanted to introduce yet another metric. It's actually a metric that was introduced by Partners in Flight in 2016 in the Land Bird Conservation Plan. And this is this concept that we're calling half-life. So how long into the future do we have until this population loses another 50% of its population? And this metric was developed by Jessica Stanton and Wayne Thogmartin as part of a quasi-extinction modeling analysis. And essentially what it does is it takes the trend trajectory of each species based on monitoring data, and then it looks at that most recent 10-year period and projects that forward, including incorporating the variability in that population. So that population is going to move forward, and at some point, it's going to have a probability of dipping below that 50% population level. It's going to lose another 50% of its population. And that time period out to which it's going to do that is what we're calling the half-life. And so Jessica and Wayne did that analysis for a bunch of land birds based on BBS data, and we included that in the 2016 plan. But now we've got new updated monitoring information for 529 species from the science analysis. So we asked Adam Smith if he could run that same sort of projection and half-life analysis for all 529 species. And so Adam was able to do that. So when I'm talking about this new urgency metric that we're pretty excited about, it's based on a preliminary analysis that still requires a bit of discussion and review, but some of these numbers are very compelling. So essentially we have this half-life metric now beyond land birds. So for shorebirds and water birds based on the best monitoring data available. And we're seeing that a lot of species have an incredibly short half-life, you know, of less than 50 years, in some cases 20 years or even less before that population is going to dip down another 50%. Okay, so we've taken this preliminary analysis from Adam, and we've come up with another 1 to 5 score that is a measure of urgency, with a 5 being birds that have a half-life under 50 years projected into the future, based on this their most recent 10 to 12 year trajectory. And scoring on down, a 4 would be a bird that has a short half-life, but a lot more uncertainty in the data, perhaps. And then there's a bunch of species like this red-headed woodpecker that have shown a steep decline over time, but also more of a leveling off in the recent time period, such that the projection does not really result in a short half-life unless you look at that full 50-year trajectory. So we've given those species a lower urgency score, but they're still sort of in the matrix. And then so we were very interested in this new urgency metric and combining it with the overall vulnerability metric and this measure of long-term decline that we had. And if you sort the species in the ACAD based on those 3 factors, there's a set of birds that come out that we're calling 3X species because they score high in the high concern category, the steep decline category, and now this new urgency metric, and they have an urgency score of 5. And so this is the group of birds that we're thinking that we are needing to focus on because they are of highest concern and there's the highest urgency. We have the shortest amount of time in which to figure out what their cause of decline is. And this is a very diverse group of birds. It includes land birds, shore birds, water birds, and I'm going to come back to this 3X category, show you a little bit more about the species in a few minutes. But there's maybe a next tier, a second tier of birds that also score or rank on all 3 of those metrics, but have a lower urgency score, perhaps because of greater uncertainty or because it's only projected to decline based on the 50-year trajectory and not the 10-year trajectory. So we have that next tier of birds that come out. And then there are groups of birds that meet 2 out of the 3 criteria that we may be interested in. So the group on top there, for example, are species that are common birds in steep decline. So they're not on the watch list. They don't have really high overall concern levels, but they do have steep decline and high urgency based on this half-life metric. And then there are other combinations that could put where a bird can meet 2 out of the 3 criteria. And then if we want to, you could go down deeper into the matrix and look at species that just meet one of these criteria of in need of attention, but are not on the top of the list. And there's an interesting group of birds, for example, that came out in Adam's analysis that weren't on the watch list and weren't even in the common birds and steep decline category, but are showing a high urgency based on their short-term trajectory. So these could be birds to literally watch that could pop onto some of these other lists in the future. So that's kind of what this initial sort of our species matrix looks like based on these 3 factors, including the new urgency metric. And so in total, there are about 250 species that meet at least one of these 3 criteria, high vulnerability, steep decline, or high urgency. And there are 46 species that we're calling now the 3X species that meet all 3 of the criteria and have high urgency based on the short-term half-life metric. So these are the species that we think are most likely to slip into T&E status in the near future, and for which it's imperative that we identify and address the specific causes of decline. So this is the group that we're proposing to be the priority species list for this smoking gun causes of decline process to focus on. And so just for a couple more minutes, just a closer look at what some of these birds are in this top list, and they're not really surprising. They're mostly birds that we've been aware of and focusing on. Grassland birds in particular, as we keep saying, are in steep decline and showing very high urgency. And there's of course an entire process just beginning now for the a new process for the conservation of grassland birds that's beginning just this week, the roadmap summit for grassland bird conservation. But another group that's very high on this list are shorebirds. Even though the monitoring data we have is not as precise for shorebirds as it is for many of the land birds, the declines that we're seeing are so steep, and especially the recent declines, that when you project them forward are really, really troubling in terms of the urgency. And a lot of these birds are already at low population size. So this is a group that definitely needs a lot more attention. It's not just the coastal big flocking shorebirds like red knot, but a lot of the interior freshwater shorebirds that haven't gotten as much attention, like lesser yellowlegs and petrel sandpiper on this list. Another group of very high concern are seabirds. We're going to hear a little bit more about those later today. Seabirds, again, we have very poor data. We don't have long-term monitoring data for most of these birds. So they're data deficient, and in some cases, the urgency is really just presumed based on the expert knowledge we do have, and their tiny populations and the high threats that have been identified. And then there are other groups of species. Most of the habitat categories are represented in this top tier list of birds. Western forest birds, including 3 species of western hummingbirds that migrate down to the pine oak forests of West Mexico, and a western hummingbird initiative has already formed around that group. Pinyon jay has a new working group associated with it. So among these birds, there are species for which conservation has already begun. Groups have come together, plans have already begun. And then there are other birds like Virginia's warbler that was probably not really on the radar. And there might be very, very little known about that species and their causes of decline. Some of the more typical species that we've been focusing on in the past, from the eastern and boreal forest, golden wing and cerulean warbler, which have working groups and plans associated with them, but also other species showing up on this list. Evening grosbeak, for which is a lot of people are noting their decline, but we don't really have a good idea of what is causing that decline yet. Connecticut warbler, we're just beginning to learn where they even go in the wintertime. There's so little known about some of these species. Arid land birds, some high profile species, of course, like greater sage grouse getting a lot of attention. Desert thrashers, there was a desert thrasher working group thinking about these birds, but also some more obscure species, sparrows that have not gotten much attention. Coastal marsh birds, salt marsh sparrow, black rail. In this case, we might have some idea what the smoking gun really is. These are birds, could be on the front lines of birds affected by climate change in terms of sea level rise, flooding out their nests, flooding out whole populations. But we're really at the early stages of what can we do to address those threats. Aerial insectivore is another group that's getting a lot of attention these days. Most of these birds, besides being dependent on large insects, also migrate long distances to South America in most cases. So interacting effects that need to be sorted out. Same with birds, a very diverse group of birds that breed in the Arctic tundra, including shorebirds and sea ducks and water birds and snowy owls, showing steep decline. So for this whole set of birds, really what the next steps are is to fill in the matrix in terms of where on the road to recovery are each of these species. And we're going to find that some of these birds we're just at the beginning of recognizing a problem. Other species we may have long recognized their declines, but don't know what's causing it. There are going to be species that are in various stages of planning and working groups have come together, and we have quite a lot of scientific data, but we might not know what that smoking gun is. And then there are species for which we may have figured out what the key threat and limiting factor is, but we're just beginning the conservation work, all the way to birds like the Kirtland's warbler that maybe is not fully recovered, but we figured it out well enough and put enough effort in that that bird has been able to be taken off of the endangered species list. And of course, that's our goal, is to move each of these species along this trajectory of recovery so that we know what the decline is, we can address it, and we've got a strategy and support and funding in place for doing that. So thanks, that's my presentation, and I have no idea if anybody's still out there.
Well, thanks, Ken. We do have some time for this. That was a great review of the avifauna. Not the most optimistic, but tremendously helpful to have it organized that way, and really appreciate that review. We do have some moments for Q&A. Remember, participants can enter questions into that Q&A icon, bring up that window and ask questions anytime throughout the presentation. So any questions for Ken that might come from participants in the audience? So one question I'm seeing, Ken, has the 3X analysis been made available on a website for discussion?
Yeah, all right, good. I'm seeing that question from Jim. Well, Tom, yeah, isn't it? So I believe that there is a sort of an internal working version of this species matrix that's been shared, for example, in the Partners in Flight Science Committee and some other groups where we're hoping to get people to start filling in these new columns in the matrix. So, so I believe there is a version, and certainly we can show, we can share this. I'm being a little cautious because some of the newest information, in particular the urgency metrics, still require more review. So, you know, there's a chance, as always, that some of these things are gonna move up and down the ranking a bit based on the scores. But we are going to make this available more widely very soon.
Right, thanks, Ken. And I would say that if we are sharing a folder for this meeting on Google Drive, and we will place copies of the presentations and the matrix with the caveat that it's incomplete at this time in that folder, so people who come to the workshop can have access to that information, as well as what I mentioned before, which would be the running conversation, the conversation board that will where we'll actually solicit ideas from everybody. Another question that's come in, is there a plan to integrate with other data sources going forward, like eBird or IMBCR, that given that BBS may not sample some of those XXX species very well?
Yeah, absolutely. And in fact, these other data sources do come in various places. You know, we don't have long-term trend data from eBird or any of these other programs yet. So the long-term trends are going to continue to be based on the long-term data sets. But eBird is being used more and more, for example, in evaluating the importance of areas within the range, estimating the size of the distribution. We're using the IMBCR data right now as a way of, in a whole modeling exercise to update and improve the population estimates for North American birds. eBird will eventually be used for that, and you're going to hear more about how eBird is being integrated with some of these other data sources tomorrow, I believe, from Orrin Robinson. So yeah, the plan is to incorporate all this data as it becomes available, but for some of our basic long-term assessment scores, we're still dependent on those long-term data sets.
Great. Ken, another question. What's the plan for ensuring reproducibility and transparency in this matrix as we continue to collect information from other folks?
Well, I mean, it's a pretty open process in that the ACAT itself is available, all that information is freely available for download. And we have kind of an ongoing review process that takes place. It has been mostly within the Partners of Applied Science Committee, but we're always looking for people, especially with expertise beyond land birds, to help identify data gaps, to correct mistakes that are in there. So, it's a very open process in terms of getting the data in, making sure we're using the best available data, and in terms of discussions on whether we're doing it the right way in terms of filtering or sorting in this matrix, and even the scoring for these urgency measures. That's brand new, and it's still being discussed and under review. So I guess all I'll say is, we're hoping it's going to be an open process that brings in any new information or expertise as we can.
Right. So thanks, Ken. Here's one final question. So with a little bit of context, the major take-home message from the 3 billion bird paper was that common species with large ranges carry the majority of the bird loss in terms of numbers, and that the field has focused too much on scarce and threatened species rather than the amazing loss we've unfortunately experienced in terms of large numbers in the spectacle. So the species prioritization matrix has many criteria that brings the small population size range restricted species to the top of the list. Is there a risk then that we face by focusing on these top species, that we might miss the large macro scale effects that might cause the bulk of bird declines?
Yeah, well, it's a great question. Of course, it's from our second author, co-author on the science paper, because we had a lot of that debate even among the authors as we were interpreting this analysis. And so the paper was focused, you're correct, was focused on this loss of abundance across common birds. And that is a huge thing. And we were partly doing that because there has been so much emphasis in the past only on threatened, rare and threatened species. But when it comes right down to it, when we're trying to reverse the declines, it's important to focus on the species that we might lose first. I mean, not exclusively, and this is a trade-off, and it's going to continue to be debated. And I would not say it's an either or thing, but our process right now that we're starting and focusing on the specific causes of declines for these birds with the highest urgency, that's really where we want to start. Conservation on the ground is more often going to be applied to these broad habitats and broad threats, but we don't want species to be slipping through the cracks. So I know Adrian didn't like that answer because this is part of our debate, and it's probably something we should continue to debate moving forward. But we want to focus on these species that we're in danger of losing, but at the same time, we clearly do want to address these broad threats, broad habitat concerns that went into this larger loss of abundance. I'm seeing all these other questions, but I'm thinking, Tom, that we don't have time, or that we need, we're going to have to come back to these.
Yeah, some of these questions we'll come back to in other ways throughout the day, but we're keeping track of these questions, and we'll find a way to answer them. Some good questions. I really appreciate the fact that the questions are rolling in, but we should move on now to our keynote talk by Steve Beisinger. So Steve is a professor of ecology and conservation bio at University of California, Berkeley, where he currently where he did hold the Leopold Chair in Wildlife Biology and is a research associate now at the Museum of Vertebrate Zoology. Steve's research centers on wildlife responses to global change and species extinction. And he's worked with raptors, parrots, seabirds, rails, and passerines. He was the recipient of the American Ornithological Society's William Brewster Memorial Award in 2010. So it's really great to have Steve with us a lot. He certainly has a lot of experience in this field. He admits to being an angler as a kid and not a kid birder. He was converted to birds as an undergrad during his final quarter when he took his ornithology course. And of course, it stuck throughout his career. Steve's going to talk to us about his subject is deja vu paradigms for diagnosing causes of decline from 50 years of effort with threatened and endangered species. Okay, take it away, Steve.
All right, thanks, Tom. Can you hear me? We're doing good, I hope. Because I can, I'm flying in the dark, which is how I fly most of the time. I hope that all of you, your friends and your family are staying well and minimizing your exposure to COVID. You know, exposure is one of the key things that we worry about when we start thinking about a search for a smoking gun. This problem of attribution, causes of change, is one that's very common in science. It's common in statistical theory as well, where they talk about causal inference. And in climate change, we've been struggling with this idea as well. You know, how exposed are species? How sensitive are they to climate change? What kind of adaptive capacity will they have? And, you know, we can ask a lot of these same kinds of questions about the 3 billion missing birds. This paper has stimulated us to go back and think hard about what's happened, but also to try and come up with an understanding. And so my job today is to try and bring together a little bit of the thinking that's gone on in the last 50 years in threatened and endangered species work, because they've been asking these same kinds of questions. You know, and there's been a lot of arguments that have gone on over the past half century. You know, at some point in time, most endangered species and most of these declining species were common. You know, maybe they were at some carrying capacity and something has caused them to decline. We know that basic population biology problem is that, you know, birth rates per capita are no longer enough to offset the death rates. And so we're seeing a declining population. And if the population gets small enough and hangs around in that small number, we might see a bottleneck occur where birth rates and death rates are more or less balancing themselves out. And at that point, a population might go on to recover or might go on to extinction. And really this is a bit of a cartoon because trajectories are never this direct, except maybe if you're looking back at that 3 billion bird disappearance trajectory that looks a lot like this one on its way down. And some species stalling out and some maybe even on the road to recovery. In the conservation biology world, in thinking about trying to recover species, there's really been two paradigms that have become important to organize our thinking. And that's how I think about these paradigms. One is the small population paradigm that really emerged from conservation biology, and the other is the declining population paradigm that had been around for probably 50 years previous, but hadn't been really well organized into a framework of thinking. Let me talk about these two paradigms, and it was really Graham Cawley who brought these ideas forward in a paper about 30 years ago. The small population paradigm is characterized by the role of stochasticity, chance events, and how it interacts with population size. So here we're talking about genetic stochasticity, demographic stochasticity, environmental stochasticity, catastrophes, how they interact with population size of threatened species. And you probably thought a lot about these when you took a conservation biology class. The way that this small population paradigm has been manifested is through population viability analyses. Often the creation of models that have tried to understand the risk of extinction, projecting populations out into the future, as Ken talked about recently. There's lots of different kinds of approaches that people can use to understand PVAs and to model populations. And a lot of them are population-based, some of them are genetic-based, some of them incorporate space, some of them don't. Some of them use counts, some of them use demographic methods. All of them can be applied and have been applied to different kinds of situations. All right, so the other approach is what Graham Cawley called the declining population paradigm. So Cawley's paper appeared actually shortly after he passed away. Cawley was an influential New Zealand ecologist who spent a lot of time also working in Australia on problems of overpopulation. And Cawley organized the thinking that had been pervasive in a way in wildlife conservation, but into a framework that made it more usable. So the first question that Cawley asked is there a population trend? We need to confirm that a population is declining or has declined, and there are established methods for doing this. It's not always easy. The 3 billion bird paper has helped answer that question for us for a lot of the species. And then the next question is, why is this population declining or in a bottleneck? Often we like to just jump to the end of that question and start assuming we know what the factors are that have caused the decline, but we really need to do a diagnosis. So we need to find out what part of the organism's demography, what vital rate is depressed, what factor or threat causes that depression in the vital rate, and then what can we do to correct or reverse these limiting factors, these threats. So Cawley was championing this approach, and he tried to champion using a scientific method to diagnose why populations have declined and which agents cause those declines. So here we are. Who's the king of diagnosis? Well, this guy, the famous Dr. House. He spent his time in Boston General diagnosing why these rare cases would come in that would perplex people. He'd get his staff around and, yep, there's Ken Rosenberg over there and Pete Mara and so forth, looking down, trying to understand what is it? And House really kind of didn't use a very organized approach. It was just trial and error. Had he been more organized, maybe he would have gotten through those symptoms and figured out what was wrong with his patients sooner. What do we think about as gold standards? When a patient gets wheeled into Dr. House, they know what his temperature is, what her vital signs are, what her blood is like. What do we have in conservation to work with? Well, we're going to have spatial and temporal measures of species or population health in the form of population size, occupancy, which is really just a question of whether a population is still occupying a location or not. The end result, I guess you could say, of local extinction, and demographic rates and causes or factors associated with the mortality or those demographic rates. Those would be the things that we would love to have as measures of health. And then we also need to complement that with temporal and spatial measures of threats. The 3 billion bird paper leads us up to that point. What do we need to understand to do that? Well, we want to use things that we could probably get: land use change, climate change, fire return regimes or intervals, grazing, oil spills, fishery hauls, you name it, fragmentation, your favorite limiting factors. More challenging to understand might be getting good databases on disease, black rails. Maybe it's sea level rise, but out here in the West Coast, we've had a decimation in our study population from West Nile virus. Cats, pesticides, fine scale habitat measures, introduced species. These are things that, there aren't established databases. They're going to be more difficult to reconstruct if we want to try and understand how they may have had their effects on 3 billion birds. But we can do it. It's just harder work. So when we started thinking about this for a study species that we were working on, the marble mirrelet, we realized that Cawley's idea of using a scientific approach was great, but he didn't give us as much guidance as he needed to. Cawley really emphasized experimentation. And so working with Zach Peary when he was a PhD student with me, we spent some time really thinking about, well, what other approaches can we use? Experimentation really turned out to be one of 6 methods that we think are commonly used or can be used to organize our thinking. So experimentation would be great if we can experiment with the factors and manipulate the things that we might expect demographic responses to relate to. So for example, Cawley was very excited about the work that Julie Savage did on brown tree snakes in Guam and showed that how when you trap them out, reproductive success increased. And that was the kind of experiment he was thinking about. But not everything is feasible to experiment at that kind of scale. Some kinds of habitat changes take much longer, for example, for old growth to develop the proper conditions. Another way that we get inference on these causes of declines is by modeling populations. And we model the population, we might compare it to some sort of independent trajectory of population size to try and determine which demographic rates are reduced. So this is the kind of thing that we can do with integrated population models. We'll hear some presentations on this in the future. If we have the data to do it, that's great. Not every kind of data that we might have for species might fit into an integrated population model. But more power to us if we can do it. We can compare populations. The third technique is comparing populations. Some populations might be increasing, others decreasing. Can we see differences in their demographic rates that might give us a clue as to why some populations are recovering and others aren't? If we have data from multiple populations, demographic data, that can give us a smoking gun. Another way that we might work with the 3 billion bird data is to look at species traits and compare those. We have trends of species with different traits or demographic information associated with those, different life histories, different exposures to threats, spatially or temporally. They could give us some information at least on the general causes of decline and their relative importance across these species, even if they might not identify exactly what the smoking gun was for an individual species. If we have data available before and after a decline, we can use the timing of decline approach to get some understanding. So here we might think about looking at environmental variables across a variety of locations or even at a single location before and after populations have declined. That can be a very successful way. And then the last approach is probably the most general in a certain sense. It's what we've often done in science, generate multiple competing hypotheses, try and come up with specific predictions about how those candidate environmental factors are acting, and then test them with different kinds of field data. We were found ourselves in that kind of situation with the marbled murrelet, a species that was one of the last to have its nest discovered in North America. Doesn't really build a nest, it just finds a big, wide, platform-like limb, makes a depression in the moss, lays its single egg. And what we knew about it was that the numbers of juveniles, or the ratios of juveniles to after-hatch-year birds in the ocean, were abysmally small throughout its range, in the vicinity of 2 to 8%. Could that be the problem that we were facing? And so when we began that kind of work, we started trying to understand the factors affecting nesting success, but also measuring adult survival. Fortunately, there was another study going on led by Fred Cook up in BC, in a more robust population that we could compare our results to. We have to have some way to compare these demographic rates in order to understand which ones might be depressed. And, signals came bouncing back at us from that comparison. We also had allometry. We had expectations based on body size for at least adult survivorship that we might be able to work with. And then our adult survivorship estimates were, for the marbled murrelet in Central California, were pretty much what we were expecting to see. But we could then try and ask these questions. Well, why was reproductive success so low? Was it because a lot of birds weren't nesting, or was it, and they were failing to nest, or was it because they were being predated? That is, their nests were failing. And what was the role of habitat, and what was the role of food? And here we begin to look at individual behaviors, and you're drilling down into a very species-specific study, developing predictions, trying to lay them out. This is the hard work, actually. It's trying to come up with a framework where you can see, in fact, that sometimes the same limiting factor might yield the same prediction for behavior. You have to have at least some attributes that would yield different predictions to help you sort across them. But multiple competing hypotheses is a general approach that we can use, and most likely the way that we're going to work with multiple kinds of data. Last but not least, we had museum collections, and they provided us information. We could use the ratios of juveniles to after-hatch-year birds to get some idea of what reproduction was like, what survivorship was like, and compare to modern techniques, and use a matrix population model approach that takes each element, each factor, and looks at the difference between them. It's called LTRE, Life Table Response Experiment, and get a measure. And so, in fact, we discovered that yes, historically, we now had elements of reproductive success, fecundity particularly, that was leading us to the decline of the marbled murrelet. All of these smoking guns were great in helping to develop the next set of things to do for murrelets. We looked across 135 species of Mojave birds recently in the Grinnell Resurvey Project, and published a paper in 2018 showing a similar kind of collapse that we saw with 3 billion birds. Here, if we look at historic occupancy on one axis, modern occupancy on the other, you can see that most species have declined. The red dots are significant declines. The orange are exotic species that weren't around when Grinnell was surveying them early in the century. And we now have a community collapse on the right-hand panel that you can see of historic species richness. So we used models to try and incorporate directly in our analysis different kinds of covariates of change, whether it was climate change, habitat change, and we found, to our surprise, it was precipitation change that best described the collapse of the bird species that we saw. And that led us to then try and corroborate that with additional data additional models that looked at what it drives declines in these birds, the need for ingesting enough food to have enough free water to evaporate to survive the difficult times that take place in the Mojave, even during warm days in the breeding season. And this was something that we discovered was important for both migratory and non-migratory species. So we can build in some of these kinds of approaches right into the analytical framework that led to the 3 billion bird decline, if we have the data to do it. Let me just mention one other dichotomy before I sum up that I think is useful to think about. And that's a kind of debate that took place in the population ecology literature about using prospective analyses or retrospective analysis. A prospective analysis looks forward, and it asks how should population health, growth rate, extinction rate, whatever, how would that change in response to a hypothetical change in vital rates? So in matrix models, that includes things like the elasticity analysis. In population viability analysis, it might be sensitivity analyses or scenarios where we're tweaking variables. Retrospective analyses look back at the observed patterns of variation in the vital rates to estimate how lambda or some other measure has changed or would have changed from different combinations of them. So like that life table response experiment, other kinds of methods do this as well. And the debate was whether looking backwards or looking forward yielded the best information to predict what vital rates should you target for management. And that debate was never really solved. I think both approaches have their value. So let me just conclude quickly with thinking about a few thoughts as we go forward to think about ways to identify causes of decline. You know, the first thing I would say is that we need to be systematic and we need to be inclusive. So thinking about testing multiple hypotheses, multiple causes, and to be prepared for more than one cause to be important. Triangulation gives us confidence. If we see multiple kinds of analyses pointing towards some kind of consilience, some kinds of independent tests and analysis, that gives us confidence, increases that we're identifying the right factors. We can try to avoid single factor thinking. You know, very likely we're going to need to manage multiple factors, and different factors might be important for different parts of a species in different parts of its range. So we might want to be thinking about tackling multiple things at the same time to maximize as much as possible population growth. Be sensible with our sensitivity analyses. You know, the most sensitive parameter of a model is not necessarily the factor that's going to limit population growth. We need to use sensitivity to understand model behavior and scenarios to evaluate the management impacts. And then last, what if that smoking gun's no longer smoking? Well, maybe we don't really need to worry about that. Maybe we can work with whatever current pinch points we find in demography now and try and find the threats to reverse those changes. All right, I think I'll stop there and see if I can answer any questions if there's time, Tom, or I guess we move into the next phase.
Yeah, thanks, Steve. That was great. I think we have time for a couple questions in terms of the schedule, so like 5 minutes for that, and we can look at what's coming through on the Q&A.
Okay, if I could see the Q&A. So Tom, you might have to be the host because I'm not seeing that, and just pretend you're back on Saturday Night Live.
Well, but here's a long, I'm looking for the question from Wayne Thogmartin in this long comment / question, but I think the question is kind of, I mean, you touched on this a little bit. The threats directly associated with a species decline may not be the one needing to be addressed to reverse that species trajectory. So a broader question I'm hoping can be answered at some point is if we're seeking to address the causes of species decline so that we can address and mitigate them, where in the causal chain do we really need to work? How do we know that? Do we go for the root causes, the underlying causes, the immediate causes? So I think the idea is so we have a kind of a hierarchy of potential causes. I assume we take it as a given that the root causes are known, that is human population growth and consumption. But for example, if disease is the causative agent of the decline, it may be because of human trade relations led to its introduction and so on and so forth. Might it be easier to mitigate the threat, not by understanding or addressing the immediate threat per se, but instead by working in the trade arena? So how do we know where to work is, I guess, the question.
Yeah, I'm seeing the questions now. Thank you. And it's a great question. I mean, I think if you attack an element of the demography, for example, that's not necessarily a limiting factor, but which you could attack and increase, then you're kind of making a long-term commitment to just manage that. You know, so you might be able to increase reproductive success, even though survivorship is what's really the driving factor. You're going to have to commit to doing that forever and ever. Whereas if you reverse what the actual limiting factor is, if you can do that, you can reach your goal of having a self-supporting wild population. We don't always have the opportunity to do that. And we may not for many endangered species. But for the common birds, yeah, it's a really tough question. I think in some ways we might also want to look at temporary things that we can do in order to address these, with the idea that at some point we're going to be able to get malaria off the table in Hawaii. You know, but until we do that, we've got to find, and what typically has been done in those cases has been attack what can be attacked. So it's not always the root question. Okay, I can. You want to feed me another one there, Tom?
Well, I think what we'll do, Steve, is move on to the panel at this point.
I think that's a great idea.
The idea of the structure of this day was to have three additional panelists present their perspective on identifying limiting factors from their particular area of expertise. And so and each one of these panelists will do a short lightning talk, and then will be followed by a bigger discussion. And maybe we can plunge into the question like Wayne asked from a perspective of having multiple people answer that question or interact around it. So why don't we launch into our first panelist? That would be Scott Loss. Scott's an associate professor at Oklahoma State University and in the Department of Natural Resource Ecology and Management. And he and his lab members study how birds and the environment are affected by human-caused global changes. Notably, climate change, invasive species, diseases, and especially the many causes of direct bird mortality, like collisions with buildings and predation by free-ranging cats. And many of you are probably familiar with Scott's work with a series of papers that covered a wide range of direct anthropogenic threats and their effects on birds. So Scott, you can share your screen and give your lightning talk, and then we'll move on.
Can you see my screen? Just checking before I get started here. Sorry for that delay.
Yes, we can.
Got it. All right. Well, thanks for those great general introductory talks. I think my lightning talk here sort of signals a transition to talking in a little bit more detail about some major specific challenges we have for identifying and managing causes of bird declines. And I'm today going to be focusing particularly on this really complicated concept of demographic compensation and additivity. And I'm going to try to keep it as simple as possible in my 5 minutes here. And we can delve into this more in the panel discussion or later if you'd like. We all know bird populations are in decline, and there's a wide variety of threats, things like Pete and some of the other speakers have mentioned, the indirect threats like climate change, the multitude of direct threats, which I've spent a whole lot of time studying in the last 10 or so years. But a major challenge is being able to understand how these different threats, direct and indirect, are interacting with each other within populations that we're trying to understand declines for. And a key aspect of that interaction is this idea of demographic compensation and additivity. There's a simple version of a definition of this, which is often used and often heard, is the idea that with addition of a threat to a population, whether it's a direct threat or an indirect threat, would the birds that die from this threat, would they have died anyway? Are they the doomed surplus? That would be considered compensation. Whereas if these birds are birds that aren't or wouldn't be dying from some other threat, it would be considered additive mortality or additive deaths upon what's already occurring. The realistic version really gets a little bit more into the actual demographics that goes on in this process of compensation and additivity. So what really is happening is that it's whether or not deaths are being offset by demographic rate changes occurring in the population. And most frequently this occurs through density-dependent processes. And just a hypothetical example here is that thinking about a species like the ovenbird, which experiences a lot of collision mortality from structures like buildings and communication towers. A hypothetical example of compensation would be if an increase in fall mortality from collisions results in increases in survival of birds during the winter as a result of reduced density of birds in the winter. So again, a density-dependent increase in winter survival with an increase in fall mortality is the example here, showing demographic compensation. It's really complicated, and I'm just going to try to hint at a few aspects of that complication here. Compensation plays out in a lot of different ways. It can happen across different parameters. In addition to the example I mentioned there with winter survival offsetting fall mortality, another example would be a density-dependent increase in reproduction following mortality. It can also happen across ages, stages, and sexes. So an example would be an adult survival rate increasing to offset a juvenile mortality rate. It can happen across timescales. In fact, almost always it happens with some level of time lag. It's not an instantaneous thing. It's a carryover effect whereby some event or some mortality source causes a rate change that is then buffered or not later on by another parameter or by the same parameter in a different season. And it can happen across spatial scale. So one population subset might have a demographic rate change that offsets a demographic rate change in another population. It's really complicated. Ideally, to understand this, to quantify compensation, whether compensation or additivity is happening, it takes intensive monitoring of multiple demographic parameters, relevant spatial temporal scales, things like cause-specific mortality from different threats, other demographic parameters, and understanding how they co-vary. And even with really good data, it can be very difficult to reach confident and solid conclusions about the degree to which this compensation happens or not. And maybe a good example there, which we might hear about a bit more tomorrow, is with waterfowl management. Even with really good data, it's not always straightforward the degree to which, for example, harvest management of waterfowl is additive or compensatory. So I'd argue that this process is really crucial for identifying and managing declines. If we can identify the things and the locations and the periods of the annual cycle where a threat, either direct or indirect, is most likely to be additive, ideally those would be the types of stressors we'd be trying to prioritize management towards. So it's really crucial, I think, to try to identify additive threats. Unfortunately, we're not really very far along in our understanding of when things are additive and when they're not. A lot of times, even in really sophisticated demographic models, there's often assumption of complete additivity, which is probably a good precautionary type approach if you're trying to assess effects of one stressor on a population, to assume that it's additive on other threats. But that could actually mask conclusions about what's actually driving declines if we're assuming additivity of some threats when maybe they're not. And going forward, I think my brief recommendations here would be just that when possible to study this phenomenon, to attempt to quantify and account for the degree to which compensation happens in populations, when considering all the different threats that are going into play to affecting populations, and when possible to account for it. But if that's not possible, which may be the case in a large proportion of examples, is at least we need to evaluate sensitivity of our models and our analyses to different assumptions about the degree to which different threats on populations are additive or compensatory. So happy to talk about that more, but I think I'm out of time, and feel free to contact me if we don't get to talk about this today in the panel or happy hour later. But thank you very much for your time.
Thanks, Scott. The way we set up the panel discussion is to have each speaker speak for their lightning talk, and then we'll do question and answers for all the speakers at the conclusion of this session. So Viviana Ruiz Gutierrez is next. She's a research associate and quantitative ecologist at the Center for Avian Population Studies at Cornell University. And she earned her BS in tropical biology from the National University of Costa Rica and her PhD from the Department of Ecology and Evolutionary Biology at Cornell. She's spent most of her career supporting and developing projects related to bird research, conservation, monitoring, and especially capacity building in Latin America. And not surprisingly, she does love mangoes.
Thank you,
Okay.
everybody, and thank you, Tom, for the introduction. And today I'm gonna kind of build off about what we've been discussing in trying to find and assess these smoking guns. And I'm gonna provide a pretty big picture overview of how we can leverage mainly the strengths of data integration approaches for improving population level inferences. Oops. Okay. So one of the things that the authors of this paper did was really provide this great important first step to get a general sense of who's declining and really use this to focus on how do we best assess this decline. My video, sorry, I forgot to start my video. So this is timely because we're also making great strides on how we model population trends. And this is work recently done by Fink et al. Looking at the temporal dynamics of trends with thrush. And I use this example because it also highlights the opportunity that we have and the potential of integrating, for example, eBird and BBS data to start getting better inferences. For example, in some of the species that either eBird or BBS doesn't get enough coverage for. We're also making great strides on integrated population models, or IPMs. And this is a really simple representation of what IPMs are. So IPMs combine, for example, the count data represented here in N that we use to estimate these trends with data on productivity, such as counts on juveniles or nest counts. And we combine this with capture-recapture data, for example, used to estimate juvenile survival or adult survival, and use this to see what is most likely driving our population decline, or what most influences population growth, represented here in lambda. And using some of the terminology that Steve used, this can be used for retrospective, but also for prospective data analysis. But what else should we account for? We're going to see a lot more examples of the details of IPMs, but what I wanted to spend more time on was to really think of what other things we need to be thinking to add to IPMs to better get at the smoking guns. And one of them is the spatial structure of trends. We weren't really able to do this before, but we really need to see how different factors play. For example, where populations are increasing, which is depicted here in blue for wood thrush, versus where populations are decreasing, which is depicted here in red. We also need to take into account spatial structure and survival. So we have variation in both trends and survival, and what you see here to the right is survival derived using map data. And we can see that is not quite aligned. Some of the places where we have low survival are places where the population seems to be increasing. So this, just looking at this, we can think that potentially for this species, and it is what has been shown, that reproductive success might be most likely driving some of the declines that we see on the breeding grounds. But we really need to take into account how to best align the resolution that we have this information in and how to incorporate this into our IPMs. Migratory species also have kind of the added complexity that trends and demographics vary across a full annual cycle. And a lot of these trends vary in magnitude in the breeding grounds versus the wintering grounds, as we've seen with wood thrush. So for example, the magnitude of the decline for the breeding range, which is about a 15% change, is not as pronounced as the wintering range, where we see around a 30% change. So we also need to really think about how do we best incorporate, for example, using a more defined multi-state approach of the IPM. We also need to think about movement and migratory connectivity to really help us define how to link our demographic rates within these models, and also how to really best incorporate transition and immigration parameters and mortality during those stages. We usually, in our traditional multi-state approaches, we assume that mortality actually doesn't happen during those transition stages. And so we really need to think about how to best link and structure IPMs so we're linking the right populations together. Another approach to think about for data integration also is approaches that kind of combine advances on improving population level inferences from individual based data, such as the work that I'm showing here done by Hooten et al., where they really tried to improve inferences on the migratory pathways of sandhill crane using individual level data. And some of the work that we're doing with Penn State and the Smithsonian as well is trying to link these two sources of information together to see if we are able to partition populations a little better and incorporate that structure into IPMs. So some considerations, resources. We don't really have many data sources that really are range wide, and some of the data sources that I've mentioned are, of course, the BBS, eBird. The only kind of recapture data that we have that's continent wide that also has information for the non-breeding grounds are the MAPS and MOSI programs run by the Institute for Bird Population Studies. And I think, in my opinion, what's really hard to get is data on productivity or data to inform fecundity. And banding data from the IBP has been used to inform that in previous IPM approaches. But I feel like that's one of the limiting factors that we do have. And there are a lot of other institutions that have either regional programs or species-specific programs who are also developing methods. And one of the interesting things from this effort would be to really try to organize these into more of an integrated monitoring network to really identify smoking guns. So some of the other considerations that I'll finish with are we really need to think about what species and results can we focus on right now using available data and available statistical methods, but also what methodological advances we need to prioritize in terms of IPMs, but also just in general in data integration approaches, especially for movement ecology, to really be able to incorporate this spatial and temporal heterogeneity that we know that's inherent to some of these populations. And also how we can use all of this information to best inform future data needs and priorities. How many GPS tags should we be putting there? How much banding data do we need, etc. So I will end with that. Thank you.
Thanks, Viviana. That was a great review of available information. Our last panelist is Evan Beakley, and he's a postdoctoral researcher at the Smithsonian Migratory Bird Center now. focusing on endangered species conservation and scavenger ecology movement. Evan works primarily with raptors and vultures and uses cutting-edge tracking technologies to reveal movement patterns of animals across continents. And given that across continent line, tracking Evan himself is another matter because he's done field work in Mexico, Ethiopia, Saudi Arabia, Micronesia, Kenya, Spain, Turkey, and Armenia. He's an avid birder, skier, rock climber, and flamenco guitarist to boot. So Evan's going to talk to us about the promises and challenges of using remote tracking technologies to identify when, where, and why birds die.
Great, thank you so much, Tom. Everybody can see the screen and audio. I'll take that as a yes.
Yes.
Yeah, so my name is Evan Beakley. I'm gonna talk about the application of remote tracking technology to help identify causes of bird declines. I think the benefits of remote tracking are largely self-evident. Modern tracking technologies can provide high-resolution data on the movements of animals worldwide, revealing migratory routes, habitat selection, and location of mortalities. Shown here is an animation of satellite tracking data from the endangered Egyptian vulture as an example. There are a variety of tracking technologies available. Things like archival and radio tags are at the leading edge of miniaturization, weighing less than half a gram, and are relatively cheap. They enable tracking of small animals, including notably passerine birds. However, if the tag is not recovered or if a bird goes missing away from a radio receiver, the fate is unknown and survival can be difficult to estimate. Alternatively, satellite tags record and remotely relay the location of an animal basically anywhere in the world. This facilitates pinpointing mortalities and estimation of true survival. Argos tags weigh as little as 2 grams today, but can cost over $4,000. Icarus is a novel satellite tracking project which promises further miniaturization and cost reduction. And current Icarus tags weigh about 5 grams and cost about $500. This figure from K's et al.'s science paper in 2015 shows all bird species worldwide sorted by body mass. The proportion of bird species that could be remotely tracked in 2015 is shown in green. At the time, the smallest satellite tag weighed about 15 grams. In just 5 years since this paper was published, satellite tags have shrunk to as light as 2 grams, enabling tracking of birds as light as 67 grams, as shown in red, and this trend is expected to continue. When planning a study though, tag cost is often a limiting factor. It is important to assess sample sizes required for sufficient statistical inferences when going into a project. Also, collaborations may help overcome small sample sizes in some instances, and data repositories like MoveBank are great at facilitating this. Further, combining tracking data with other survey methods, as Viviana pointed out, can help to get from individual to population level inferences. It is also important to consider potential impacts of tagging birds, particularly with endangered species. Meta-analysis of 214 studies on birds showed small but significant effects of tagging on survival and reproduction. The 3% tag to body mass rule is pretty widely accepted, but I think it's important to consider lighter and lighter options if and as possible. If there's an option, it's great to be able to test tags on captive birds prior to release to better understand potential impacts. Importantly, studies should also assess the return rates of tagged versus untagged birds to be able to quantify the effects of tagging. I think also importantly, we should think of tracking data as belonging to the animals, not to us as researchers. And with that mindset, the data should be shared and archived so any tracking data can be used to its utmost. There are several considerations regarding how to identify mortality once you've deployed remote tracking technology. In purchasing tags, it is important to make sure that the technology you plan to use will work throughout the species range. Things like Icarus will have polar limitations. GPS tags can have, dead zones. And if birds go missing in a dead zone, it can be hard to know the fate or impossible to know the fate. Also, different tag sensor options such as battery voltage, temperature, and activity can vary by transmitter manufacturer, and these can really help differentiate mortality from tag failure. The harness design is also an important consideration. A lot of researchers are now putting out weak link harnesses that are planned to fall off after some time, which can benefit the bird, but can confound determination of mortality because drop transmitters quantitatively look very similar to dead birds. I suggest also ground truthing data and not just relying on data analysis to assess mortality. Ideally, partners and protocols to recover and investigate downed birds should be established prior to tag deployment, and money should be set aside for funding for tag recovery. And it's also important to think, even if you recover the tag or bird, how are you going to confirm the cause of death? I think it's important to consider funding for necropsies. So in conclusion, remote tracking is perhaps the best way to assess bird mortality in the 21st century, but it's really important to plan ahead and don't expect it to be easy or to be a panacea. And then I just wanted to list these 3 articles that I think are particularly valuable for kind of investigating this topic a bit further. So thanks for listening and feel free to reach out.
Thanks, Evan. I'm going to put us in gallery view now, so that theoretically everybody can see all the speakers. And Evan, you can stop sharing, I guess.
Yeah, I'm looking for how to do that.
There we go.
Okay.
So at this point, we have about 40 minutes left for the workshop today. And so I'd like to open up the question and answer to the audience. Folks can ask questions of any of the panelists or of the panel in general. And we'll try to sort through those questions. While we're waiting for questions to come in, I do have one that I'll ask. Hopefully this won't be too broad. I'm in listening to the presentations, both the overview that Steve gave and then the ways in which we can think about using particular techniques, both at population level and at the level of individual birds. My little pea-sized brain is having an awful hard time accommodating all that. And so the question I'm going to ask is, what if we have a species of bird where we just don't know anything about it other than the fact that we're pretty darn sure it's declining? Where do we start? And Viviana, you can unmute yourself. There you go. And Scott as well. I don't know anything about why this bird is declining. What do I do? Where do I start? There's like so many different ways of approaching this and so much. Where do I go?
Well, I'll jump in as a starter. I think Colley would suggest sitting down and making a list of all the possible factors that you think from your armchair would be responsible for the decline in the species. And that would be a good starting point to then begin to perhaps look for data that might be available, organize studies. That would be where he would start with his declining population paradigm, and trying to take advantage of information that's there. Have we actually taken advantage of all the information that's available to inform us about changes in the environment that have taken place to result in the loss of 3 billion birds?
I think I have to agree with that because it's one of the, they're always what I call data orphans. A lot of data sets that just haven't been used, and think just in previous projects, we just think of what data is available, or what's nice about having citizen science data or volunteer-based data, such as MAPS and MOSI also available, is that you have kind of a starting platform, and then you can see what other information you can layer on top of that to just have a starting point. And then you can say, for the example that you guys will hear more about tomorrow, that ordinal percent on tricolored blackbird, it was a little bit like that. What data do we have? What can we know? And really trying to think then, okay, if it's one vital rate or another, what factors most influence those vital rates? And I think that's where we can also kind of walk that line of the difference between research and monitoring. Because I feel like at this point, it's when research comes in and we can actually say, okay, then what is really influencing female survival? What is really influencing reproductive success? And monitoring kind of gives us that common ground to really at least answer some questions that then we can use to build hypotheses.
I mean, just a simple point, but I think it's also just, you know, going out and spending time with the species of concern and hanging out in its habitat, and making sure that we don't lose track of that in the 21st century with all the remote sensing and tracking and everything.
My answer is a little more complicated from the additive compensatory side of things. There may be some broad trends, say you are able to bring together some data sets that are already available. There may be some ways to identify broad patterns in how different drivers or mortality sources and indirect threats are interacting with each other, but it would seem difficult to get the details of that without some focal monitoring of specific causes of death and specific effects of stressors on demographic rates. So there may be a way to get at that somewhat with existing data, and probably some follow-up monitoring needed as well.
So here's another question. You know, science, it seems like the science will take a while, and especially trying to zero in on what the really specific cause of decline is, given all these great tools and the ones that are increasing now. How can we pursue this path of developing these key insights using science? How can we pursue the needed science, but at the same time take conservation action? How do we do that trade-off between if we have some idea of what broad threats might be, taking conservation action, and how do we sort of integrate that path toward needed science and more science versus got to take action now where things are really urgent? That's a big question, I suppose.
Imagine perhaps, you know, again, with the additive compensatory thing, and the idea being that you would need a lot of intensive research to figure it out for a specific species, not stopping that type of research vein, but also looking to see if there's existing information from sister taxa that you might sort of use as a placeholder as you start to delve in more to that particular species, and then adaptively update whether your sort of thoughts are accurate or not as you get the data from the actual species of interest.
Yeah, I was just going to second that, which hopefully, you know, we're often kind of funding limited, but hopefully it's not necessarily an either or, that we can do both simultaneously. To some extent, we can try to start addressing what we know while we're also forwarding research and then kind of updating that as we go along to be more effective in conservation.
So many of the habitat implementation people, JV, science coordinators and coordinators would say, you know what, I've only got certain things that are at my disposal, certain tools. My toolkit is relatively, you know, it's not that great. I don't have everything I don't have all options available. I can maybe introduce fire, or I can remove brush, or I have a limited set of things that I could do in terms of dealing with habitat. What do I do, or how do I incorporate making sure that while I operate on a fairly broad scale, the species don't slip through the cracks, and we may lose individual species. I mean, Scott, you hinted at it, I guess, by thinking in some way about an adaptive approach, sort of merging the discovery of information with the actual application of some sort of management activity. Anything else that comes to mind?
Well, since I've spent so much time thinking about large mortality sources on sort of broad scales across all birds, it's like, for me, I think of, well, big threats like cats and windows, which we've estimated to result in large total amounts of mortality. Like, maybe it's an analogous adaptive approach is to like try to invest in those while we figure out what the specific drivers are for individual species. If there's big overarching threats like habitat loss, obviously, or big direct threats, to focus on going forward and addressing those while we figure out details of regulating factors for individual species. It's just one idea.
All right, thanks. I'm going to turn to the Q&A. This is a question for Steve. Can you continue the marble murrelet story and let us know what conservation recommendations were made from your work? And were these recommendations implemented, and if not, why not?
Yeah, well, so several things came out of it. We also used, besides the effort to understand demography, we used the specimens to look at long-term changes in diets of murrelets. So looking at stable isotopes of the feathers help us to identify that there was things going on in the ocean, that murrelets were feeding much higher on the food web than they are now. So a focus in the conservation sphere became near shore, understanding what's happening with the small fishes, the bait fishery industry, which is unregulated throughout most of the West Coast. And then the fact that we were seeing nest failure inland. So part of that story helped us to understand why birds were failing to nest. And then the nest failure part of the story identified corvids, no surprise, as being a big problem. And so that led to two recommendations. One was to remove campgrounds out of the best habitat because campgrounds were attracting corvids. And the second was to do a lot of camper education and reduction of food supplies for corvids in the campground areas. So we failed to get any campgrounds moved out of the spectacular old growth that exists in California, but we were very successful at getting state parks and national parks to both educate campers and help them to recognize that they needed to reduce food availability that was attracting corvids into those fine old growth areas. And then under the radar, federal animal damage control started trying to control corvids and has had some success there. I can't speak yet to how well that's translated into population changes for the murrelet in the region. But I think at least the research informed those factors. Yet again, here's a case where, there were probably multiple factors involved, right? The old growth disappeared from the region. 85 to 90% of the coastal old growth, redwood and Doug fir is gone. And now we're dealing with secondary problems caused by that. So until we eventually solve growing that old growth back, we're limping along trying to increase reproductive success where we can.
Great, thanks. This is a question that came up earlier from Kristen Rube. And I'm scrolling up to it here. We know that drivers of population declines do vary regionally. Do you worry that the approach that prioritizes rare species with limited range size will obfuscate our ability to identify drivers of regional population declines? And I would say that I think when Clark Rushing talks tomorrow, he may have some insight on that one. But if anyone wants to take that question, please do.
I think that was brought up when Ken was talking. I think
It was, yes.
it's
So,
specific to kind of the PIF assessment and that prioritization. I don't know if Ken wants to answer that.
but I think it also relates to the to the things Steve was talking about when he was talking about the difference between, focusing on in a really isolated way on a species and trying to come at it from a broader perspective.
Yeah, and I think we can take the same ideas to go across the broader perspective of multi-species evaluations here. So are there regions where we can see large-scale declines taking place more than other regions, right? And then what is it in those regions that's changed? Is it agricultural crop cover? Is it pesticides? Is it land conversion into urban sprawl and ranchettes? We could be asking some of those kinds of questions. I think with the data we already have, recognizing that we will want that fine scale data on reproductive success and survival, but in the interim, we have some wonderful long-term changes that we can work with at the population size level that we could try to connect better to some of these kinds of factors.
And to add to that, what's been exciting about seeing spatial trends is that you're able, as we are able to get that information from more and more species, just like being able to identify key areas where they're of high abundance during the migration period, or where we know that a certain species of interest that's part of their core range, being able to compile and identify areas where a significant portion of the population is declining across multiple species. That also, I think, will help then kind of bring in that information that Steve was talking about. What is about this area that is causing a decline across multiple species while they're actually not declining in other parts of the range? So being able to think and visualize that spatial structure and trends, to me, is a game changer that way, because you can look at big patterns in a way that we haven't really been able to look at before.
Here's a question. Steve found that climate change driven changes in rainfall were critical in driving population declines for a bird community. I suspect that this type of impact will show up for a lot of species. To the panel then, any ideas on what can we do to address limiting factors like climate change? Like changes in precipitation.
Yeah, it's toughy. The climate change issue, I think, is also showing us how unpredictable some of these factors are in driving changes. And with precipitation, precipitation change is bound to interact with temperature change in places. So places that are getting hotter and drier are going to be more problematic for birds than places maybe that are getting hotter and wetter. And we even have some places that are getting cooler and wetter. In California, we have everything that's taken place over the last century. I don't know that I have the answer for it, except we'll hope there's some adaptive capacity for birds there.
My only thought is if we can try to use some predictions out into the future and be proactive about where, you know, habitat that we might predict 10 years out or 20 years out or 50 years out is going to be really valuable, or that is going to be really impacted. And so we can just try to get a little ahead of the curve. I mean, as ornithologists, not going to stop climate change, but maybe if we better understand the impacts and where it's going, we can be a little proactive about addressing it.
But I think just like climate change, there are a lot of factors that we won't be able to influence, and even some vital rates that we can't influence. And so I think the ability to do some perspective analyses, there are a couple of good papers that are examples, like Saunders et al. And others that you can kind of play with different management scenarios or different things that you can influence. So for example, if climate change is impacting reproductive success, but we can do something on adult survival, and both of those factors influence population growth, and then maybe that's something that we can play with. But I think there are going to be a lot of smoking guns that we can't address and that we kind of have to get creative in seeing how we can address them.
Well, yeah, and I think kind of building on that, climate change just really, it challenges our entire conservation paradigm. You know, what does a baseline mean? And when the climate is changing and the conditions in a location, maybe even the conditions that supported 3 billion birds more, might never return to us in the same way. So we're constantly trying to think about the baselines of how things were, the conditions, the ecosystem processes and other climatic conditions that help sustain where things are. And as Evan said, Viviana suggested, where things will be. You know, so we've got to, I think, combine those, and more in the climate change. And I think precipitation is jumping up to be a big factor, and probably less well understood from our climate models.
My comments probably follow very closely off what Viviana and Steve are thinking, but at least understanding if there's climate-related stressors that we can't do something about in the immediate future, understanding how those factors constrain everything else that we're trying to do. And maybe the easiest way to think about this, I tell my senior global change students this, and thinking about management relevant ways of thinking about climate change is, well, if you're, say, setting a harvest rate for a game species, you might have to change your harvest rate if climate change is imposing some constraint somewhere else in the population. So at least understanding and accounting for it in other things we're doing in terms of managing populations, whether it be things like direct harvest or incidental take, etc.
Yeah, great answer. This is a general question to the group, including Ken and Pete, related to habitat loss. And in using that habitat loss idea as an umbrella to answer what has caused the decline 3 billion birds. So always coming back to habitat loss. And I find it hard for individuals, people, and even managing agencies to relate to just habitat loss. There are obviously different factors influencing habitat for any given species. What are everyone's thoughts on having this more specifically defined, other than just habitat loss, both for researchers, managers, and the general public? For example, with regard to grassland birds in New England, habitat loss is often thought of as a conversion of those habitats for a different land use, while early season mowing is likely just as equal a cause of habitat loss. I wonder if the panelists find it harder for individuals to relate to the causes and problems contributing to declines. So how do we move from habitat loss to something more specific? Is, you know, I think maybe one part of this question, and something that both managers and or the public can more easily relate to.
don't think I have the best answer for that, but I've had to think about this a lot because as we've written these papers in the past on numbers of birds dying from direct threats like collisions, I've frequently gotten a question like, well, how does that compare to habitat loss? And it's really hard to quantify mortality from habitat loss, but if you think about it a lot, think about what is actually happening to birds that are affected by habitat loss. I don't even think we've clearly identified that. Some birds are dying, their nests are getting destroyed during the habitat loss process, but beyond that, a lot of birds are moving off somewhere else and they're somehow dying in some other way that we don't necessarily make clear to how that would be managed, whether it's pushing birds into subpar habitats to breed and they experience higher breeding failure rates, or they're being forced to cross more roads and collide with more cars. But maybe thinking about habitat loss as like the link of habitat loss to some of the more direct manageable things might be one way to conceptualize it in a more relevant, management relevant way.
You know, we talked about various new technologies that in different arenas, in the arena of statistics and analysis, in looking at tracking devices and new ways of thinking about climate change and other aspects, tracking individual birds, thinking about broad threats. What do you see as the most promising sort of intersection of these technologies? Where do you think, for example, the future lies in bringing some synergy in technology advances together to really better elucidate causes of decline? Where do you see the bright spot in the future for bringing some of these technologies and methodologies together?
Well, I guess I'd say hearing, you know, the progress we've been making on tracking of individuals, and as Evan talked about, gives us a chance to connect not just the whole life cycle pieces to understanding limiting factors, but probably would also let us get at the kinds of detailed causes of mortality that Scott would love to know. You know, being able to actually do a better job of being able to get at the cause of mortality, which is really tough, probably, as Evan even indicated, when you find something on the ground. That's when you have to call in Dr. House, and he has to help you figure out, you know, what's going on. Was this bird just drunk on berries and bashed into the window? Or do we have a pesticide problem here? Do we have some interaction with a predator and the condition the bird was in prior to death? All of those kinds of really challenging things to get at, but which you'd love to know.
Tom, you mind if I chime in on that one?
Go ahead.
Yeah, I think the other piece of this is that tracking will allow us to define populations a little bit better throughout the annual cycle. And we also have to remember that it's not just tracking. Some of the work that's being done on identifying genoscapes, specific population structure across breeding ranges, and how those populations move down into wintering areas or even on migration, work that Christian Ruega is doing and other folks, is also providing us a different perspective of what these populations are doing. And that's going to allow us to start doing some of the things that Viviana was talking about, and starting to look at spatial variation for linked populations throughout the annual cycle. This is stuff we have not been able to do before. And so we can use the power of space and the power of time to start asking these other questions about how these things are changing across space and time. So it's not just the individual tracking, it's also tracking of these populations and these other techniques. So it's really opening up a new book in our ability to understand what's driving these fluctuations.
Yeah, I might just add to that, which is, you know, I think that there's two really simultaneously exciting things happening in the tracking world. One is miniaturization so that we're being able to track more and more species, which is great in and of itself. But perhaps almost an equally important thing is bringing the cost of the units down so we can actually deploy a lot of them. And so I'm certainly really excited about Icarus and the future. I mean, it's just launching this year basically, and we'll see where it goes, but there's a lot of promise there to be able to hopefully get from, you know, tracking a handful of individuals from a single population to being able to put out hundreds or thousands of units, to be able to look at not only, you know, the individual behaviors and all the diversity in individual behaviors, but also the interactions between individuals of the same species, or between interactions between individuals of different species. And so as that grows, I think, yeah, I mean, it'll open up a lot of questions, but has the potential to really help identify specific causes of mortality and drivers of decline.
I mean, one thing that I was wondering was listening to Viviana's talk, where she talked about, you know, the information we're able to get through banding operations like MAPS and MOSI, and, you know, thinking about the capture of birds as providing information that's, I mean, it's as Pete has often said, every mist-netted bird is a museum specimen. There's so much information in individuals, but should we be thinking about the ways in which, say, a MOSI or a MAP station could be paired with nanotag birds and MODIS towers at the same location? Should we be thinking about taking some of these technologies and really focusing them together, sort of devoting more of the conservation community's efforts toward figuring out where the overlaps are and exploiting them, as opposed to, you know, going about it separately? What are the possibilities there, and how might we go about that better?
They might not have to just physically overlap, but at least I think somebody also, Jessica, mentioned a comment that it's really hard to go back and find all the available data sources. So it's really hard to go back and dig through and link information together that was never meant to be linked together. That's stored in very different ways. So I think to the level that we can, especially now using very limited resources, that we can leverage support for multiple programs that are larger in scale, like MAPS and MOSI, that we can layer individual research objectives, but also at the same time contributing to kind of larger scale monitoring that will be useful for years to come. It doesn't necessarily have to come from the exact same population sometimes, but I think if we did a better job of aligning where some of these efforts happen, or at least helping leverage funds, it would be very useful. And the concept of having better integrated monitoring networks is really hard when everybody has gone so far independently in their monitoring efforts. So it's kind of really hard to bring everybody together. But I feel that citizen science provides a bit of a platform where something is volunteer-based to really bring that together a bit more as kind of a unifying source of information that we can promote the collection of, for example. But resources, if we can get better information on connectivity, but at the same time, what we're connecting, we have at either end better information on demographics, it's really a win-win situation. And so pairing those approaches just makes sense in general, and is much harder to pair them later.
You know, leveraging citizen science efforts is something we haven't really, you brought up, Viviana, but we haven't really talked about that. We've talked about sort of science more from the academic perspective. And, you know, obviously eBird comes to mind, but there are many other ways in which perhaps citizen science could be incorporated in with a dual goal of not just assisting and improving the science, but also in perhaps building capacity in some way that's hard to discern in the moment toward a greater a public that's more receptive to reversing declines of birds and that kind of thing. Do any of you have any experiences that you would care to relate with respect to citizen science in your work? Here's looking at you, Scott.
Yeah, I mean, I'm thinking of our bird window collision work, where a tremendous amount of data that went into our national estimates of bird collision mortality and species vulnerability came from major cities and volunteer monitoring efforts through a number of entities. And even wrote a paper about sort of how challenging that process was, to not have been in at the ground floor as they were developing their monitoring efforts. And there was a lot of problems and biases that went into our analysis because all these citizen science programs were designed in different ways with different reasons originally, but just sort of trying to coordinate those types of efforts from the ground up, I guess, could be very important depending on the type of data being collected.
At least for Latin America, where I focus most of my efforts, it's for example, we've been, even when I was an undergrad, we were doing point counts the same way, and everybody was storing point counts, whether they were researchers or if you were bird watching, various disparate databases. So one of the things that we have started is it's just going to be released from Conabio. I don't know who from Conabio is on the call, if Humberto's on the call, but we have a joint manual that's called Proalas, and it's a citizen science manual, but it also has different chapters that explain how we can use a protocol for research as well, and to inform management, for example, forestry management in Latin America. And we use eBird as a platform, but it's really kind of more of a monitoring initiative with citizen science that's pretty flexible. So that's been really rewarding because it has provided a common source of information in a way for folks who want to do point counts. People are doing point counts everywhere in Latin America. And so we can sometimes provide a bit of guidance, so then we're able to access that information. Instead of just having more quantity, we're actually able to get quantity and quality and also impact capacity building. Since that data can easily be analyzed using occupancy models. So that's kind of one example that I think it will be downloadable from the Conabio website as of next week. But that's kind of been a useful approach that combines these two.
Thanks, that sounds great. Well, I think we're sort of approaching the announced ending time for this workshop, but I want to thank both the early presenters, the speakers, and on all the panelists for participating. It's been really great. It's a tremendous amount of information to digest. With your permission, we'll share your PowerPoints on the site. I want to point out to everybody that at the bottom of the agenda, which went out with the original invitation for this webinar workshop, there was a link to a folder, a Google Drive folder, and there's a Google Drive document in there with the word, I think it's, anyways, causes of decline whiteboard or something like that, where I'm encouraging everybody to put in comments that might have been written in the chat and to keep that dialogue going as if it were a chat. It's going to be up there and available over the next few weeks, and the organizers of the workshop will look at that document and garner ideas. And specifically, I would ask people to think about what might be the next steps for this road to recovery effort. What might we do after this webinar is finished? What do you want to see happen subsequent to this first presentation, first pair of days? Reflect on that and put those comments in that Google Doc that's available in that shared folder. that would really be appreciated, and any comments that you have as well. I'd also encourage you to come to the happy hour, which is going to start in half an hour. So, and that's on a separate link, and that's requires registration, but the registration is still open, and the link to happy hour is also on the agenda. You can click on that link and register and come. And what we'll do in the happy hour, the way that will be structured is we'll have a meeting of all of us for 5 or 10 minutes, and then we'll break into breakout groups, and the speakers and panelists from today and the speakers and panelists from who you'll hear from tomorrow will be distributed among those groups and visiting them. So it'd be an opportunity both to socialize and also to have conversations that that aren't possible with a group of 120. So I encourage you to sign up, register for that happy hour, and bring your favorite local brew. You have to show that. That's one of the first things. And then enjoy talking with one another. So again, I want to thank everybody, both the presenters, panelists, and certainly the folks who participated as participants in the workshop at the audience, and hope to see you all back again at 1 o'clock Eastern tomorrow after a nice and engaging happy hour tonight. So there we go. Thank you very much.
Thanks everyone, and thank you, Tom, for
Thank you, Tom. Thanks, everyone.
keeping the whole thing going. This was great.
Thanks,
Yeah.
everyone. Thanks, Tom.
Take care.
Speakers, a little bit.